We're going to first define polygons. Polygons are two-dimensional geometric figures with the following characteristics. They are made of straight line segments. These first four figures are all polygons because their sides are all straight segments. Second, each segment touches exactly two other segments, one at each of its endpoints, which sounds kind of confusing, but if we think of it this way, here's a line segment. It ends at these 2 points. So this one segment touches two other segments, each at their endpoints, which essentially means that these polygons have segments that end at each other's segments. And lastly, a polygon will be closed. It divides the plane into two regions, an inside and an outside. There's no leaking between the inside and the outside. These shapes are not polygons. These first two shapes have rounded sides. The sides of these shapes are not straight lines. This polygon, or this shape, is not a polygon because the segments don't end at endpoints. If we look at this segment right here, I have an endpoint here and an endpoint here, and this line segment hits the line segment not at an endpoint but in the middle of that line segment. And this last shape is not a polygon because it has two mini interiors. In this shape, we have an interior here and an interior here. So we've actually divided the plane into 1, 2, 3 regions. Now if I cut off this bottom triangle, then I would have a polygon. If I cut off the top triangle, I'd have a polygon. But these two shapes together creates a non-polygon. Let's look at the ways we can classify polygons. The first way to classify polygons is based on the number of sides. If a polygon has 3 sides, then that polygon is classified as a triangle. If a polygon has 4 sides, 1, 2, 3, 4, 1, 2, 3, 4, it's classified as a quadrilateral. If a polygon has 5 sides, it's classified as a pentagon. 6 sides, 1, 2, 3, 4, 5, 6, is a hexagon. 7 sides, 1, 2, 3, 4, 5, 6, 7, is a heptagon. 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, is a octagon. 9 sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, is a nonagon. And 10 sides is a decagon. Memorize the names through a 10-sided polygon. Anything after a 10-sided polygon is named by the number of sides. So if we have a polygon with 11 sides, there's a name for it, but we're just going to call it an 11gon. And a 12-sided polygon is just going to be a 12gon. There's a name for a 12-sided polygon, but we're just going to call it a 12gon. If we look at these polygons, both of these polygons have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's a name for these, but we're just going to refer to them as 17 gons. In general, when we don't know the number of sides for a polygon, we're going to call that polygon an n-gon, where n is a number that stands for the number of sides. So an n-gon could be a triangle or a hexagon or a 25-gon, We just don't know how many sides at this particular moment. A second way to classify polygons is based on whether they are concave, they are caved in. We have an angle that is more than 180 degrees. These polygons are all concave. Any polygon that has an angle measuring more than 180 degrees is concave. These polygons are not concave. The opposite of concave is convex. Every angle is less than 180 degrees. So the two that you need to know for concave and convex, remember, concave dents in, it's caved in, and a convex polygon is opposite of that. It is not concave, it's convex. A third way to classify polygons is based on whether those polygons are regular or not. A regular polygon has all sides the same length. But in addition to having all sides the same length, all the angles are also the same. So each of these polygons are regular because all of their angles are the same and all of their sides are the same. Now the polygons below are not regular. The name for shapes, polygons that are not regular is irregular. Now be careful. A polygon such as this rectangle has angles that are the same. But since our sides are not congruent, this shape is not regular. Be careful. A lot of students see a pentagon shaped like this where all the sides are the same, and they think that this is a regular pentagon. But if you look, the angles are not congruent to each other, so this shape is irregular. Each of these polygons can be classified as having line symmetry. Another name for line symmetry is reflection symmetry. The folding line on which these shapes reflect is called the line of symmetry. These polygons have line symmetry. The line of symmetry are shown as dashed lines. Notice that some of these polygons have more than one line of symmetry. So all of these polygons have at least one line of symmetry, so they all have line symmetry. These polygons do not have line symmetry. There's not a name for these shapes when they don't have line symmetry. We just say, no, they don't have line symmetry. Now be careful. This last polygon right here looks like it should have line symmetry. It looks like I should be able to draw a line like this and have line symmetry. But if you look, these two halves are actually congruent to each other. They're just not reflections of each other. So this triangle and this triangle are congruent to each other. They're just not reflections. So this shape has symmetry, but the symmetry that this shape has is rotational symmetry. So symmetry rotational symmetry is not the same as line symmetry.